Is the mic on? Yes, it is, I guess. So hello, I'm Michal Rutkowski, and this is joint work with my colleagues Dmitry Stratiychuk and Philipp Fehre. So Dmitry had to leave, unfortunately, already to catch his plane, but Philipp is here, so we can talk to him and me afterwards if you want. And we are part of a team, or we are the team called the SOA team. And this is about the work we did recently over several projects. Okay, so can we fix the alignment a bit? Okay, fair enough. So briefly, what is this talk about? So I will first tell you a bit about the challenges we faced, which kind of led to this work. Then I will discuss why we actually turned to event sourcing as a solution. And the bulk of the talk will be about how we rolled it out and what we've learned from that rollout. And I will conclude with the kind of future work we want to do in this area. So what is Yammer? Yammer, as the words say, it's an enterprise social network. But what that really means is it's a tool which helps teams collaborate. We try to focus that collaboration within groups. But we also provide more kind of broader spectrum, like a broader audience discussions, and also we provide private discussions. So there are quite a lot of features. So if you look at those two slides, the left-hand side shows the inbox view. So this is the kind of content which is related to you, which you haven't read or left for later. And on the right-hand side, you see a group. So this is actually the Yammer engineering group. So that's where we the broad engineering team discusses stuff. So our core feature is message posting and messaging, if you like. But in reality, if you look at the site, a single message triggers a single message posted event triggers a lot of actions, which are powered by different components, which are relatively independent. So a message is typically addressed to somebody, so it has to end up in your inbox, or to addressee's inbox. But it's most likely it's posted in the context of a group, so we want to deliver to a group. But we also have aggregation views for messages, so if somebody is following me, they will also have a view which shows my messages or messages of all the people they follow. And if I'm very popular, then that can be actually an expensive thing to compute. But also message posting triggers our ranking system. So you see on the right-hand side, there's a little window which has my contacts, and it's sorted by kind of popularity, if you like. But it's, again, that can be affected by who I post to and whose messages I like, who to reply to, etc. Also, on the left-hand side, you have the list of groups. They have counts. These need to be updated. There's some real-time notifications, depending, like if I get something to my inbox, some action happens. Again, this is another flow. So the gist of it is that a single event actually powers a lot of systems and impacts a lot of systems. So we are kind of a consumer product in the sense that we are actually trying to discover what our consumers need and what actually makes them engage in our product. But at the same time, we are a corporate product. So people use Yammer. They actually quite often pay a license fee these days to actually get work done. So to make that happen, to make them believe that they can get the work done, we commit to an SLA. So they can count on us being up. And our external-facing SLA is 99.75, so 99.75. That's roughly 40 minutes of downtime a month. And that's not a lot. And if we don't meet that SLA, we have to pay money. And our reputation is hurt as well. So that's very important. But also, since we are trying to attract customers, it's not like Yammer is not adapted for top-down decisions. We want to provide a good quality experience, so performance is a big chunk of it. But internally, what's important to us is velocity. So maybe you've heard some other kind of more product-focused talks from Yammer, but we measure everything, and we drive our product decisions based on metrics. We run A/B tests, and we see how people behave, and if a feature is wanted or is used, then we keep it. If not, we potentially scrape it. So in that context, spending too much time building a first version of feature just doesn't work. Because if we have 80% chance that the feature will stay, we don't want to invest too much because it just is too costly. But what's quite important is that these two are a bit slight odds, right? If you want to deliver things fast, it's very difficult to meet your SLA. So the team, Philipp and Dmitry and I are working, and its focus is actually to help our engineering organization meet these two potentially conflicting requirements. So we want to enable people fast feature building, but at the same time not compromising our SLA. And in broad strokes, what we do is we drive discussion, we try to adopt better patterns mostly around architecture, but we also try to build tooling and or adopt if there's something off the shelf to make that possible. So to give you an example of what kind of work we do is we are currently working on better tooling for process for release management. We have quite advanced continuous delivery, but there's always room for improvement. We also want to get more advanced testing involved, like, for instance, load testing before things are released so that we don't have performance regressions. We also drive kind of discussion and tooling for best practices around service design and development. So we encourage people to test for failure, especially kind of latency type failure around higher latencies. We build tools which help engineers meet their quality of service guarantees. This is not to be confused with the external SLA. We want still our components to kind of commit to some sort of quality of service SLA and make it easy for engineers to actually meet that commitment. But we also do a lot of work around inter-service integration patterns, and this talk will be mostly about this. So this will be a familiar story probably to most people, but Yammer started as a small startup. It was a Ruby on Rails mono app backed by Postgres, very easy to develop, very quick. Great. But as we became successful, more features were developed, it just grew, and it grew to a quite unwieldy size, both in terms of management, like maintenance, but also kind of operational concerns. It was difficult to deploy, it had single point of failure, so it was very difficult to develop features because the sheer size of the code base was such that it was very difficult to know what's happening. And also performance was hurting because we were reaching the limits of our Postgres DB. So what we started doing is we started extracting performance-critical components out of the app. That's how Dropwizard was born actually, of the first few such extractions. The typical pattern was that we would use Rabbit to facilitate an asynchronous write to the extracted functionality. That functionality would usually have its own data store and would provide some sort of a materialization of a more complex, expensive view, which would then be back the actual Rails mono app. But as we went on, we started extracting more. We started actually creating user-facing services that required authorization, authentication, access control. So we had to create this as services. We started trying to limit the amount of code we add to the mono app because we didn't want to make it grow. We actually wanted to make it smaller. So this was going quite complex. And we are quite early adopters of extracting things into services. So by around the time I joined, that was the service dependency graph in Yammer. Quite difficult to comprehend. And that was mid-2013. So that's 3 years ago. Today, nobody even attempts to draw our dependency graph. I think we have 100-something services, a few hundred nodes. We operate it in our own DC. We are moving to Azure, but it's basically there are multiple. It causes multiple pain points because we arrived effectively at a distributed monolith, and we tried to get out of that. So, what were the real issues we faced? So, our feature development slowed down quite a bit. We have too many inter-service dependencies, which makes it difficult to build something. Our services are pretty chatty, which effectively means that we haven't drawn our boundary, like domain boundaries well. So developing a new concept typically requires iterating over multiple services, which is way more expensive than it should be. And we have too many inter-team and cross-time zone dependencies. So different services are kind of maybe not owned, but maintained, or expertise around them is quite often contained in one team, which is local to an office. That's, again, if you have features which cross multiple, go across multiple services, that's, again, quite a bit of a headache for a project team to roll out a feature in such situation. But not only that, but it also made it difficult for us to meet our SLA. We had too many external dependencies on the read and write paths. So that means the chances of failure were actually pretty high. And making the read or write path resilient required quite a lot of investment, because every component had to be super resilient, more so than we would expect. We had a shared DB, again, a nice a common anti-pattern. Slows us down, single point of failure, easy to break. Furthermore, with such a complex dependency graph, it was beyond comprehension, so we had unexpected transitive dependencies, which we typically would discover during an outage through cascading failures. And there's a lot of good practice around inter-service communication, like circuit breaking, to prevent cascading failures. But still, we managed to see quite a few of those because of the complexity of our graph. And again, because it was so complex, it's difficult to test. I mean, the amount of test case complexity is immense. So it was actually relatively easy to roll out a breaking code change, which would slip through the cracks. So yeah, about a year ago, it was really bad, I would say. So we looked towards event sourcing. So there's a very good article on MSDN under the term event sourcing. That's where I took the diagram from. But basically, what we have here is that instead of keeping the end state of the system, we focus on the events that lead to the state change. And we keep them in an event store. And our views are served from services which actually subscribe to these events in some fashion and materialize a view. So a new feature would typically be a new view on an existing event stream. But sometimes you will also add an event stream. So here this is a very simple example. We have a cart with items. So the events are create a cart, add an item, remove an item. And the shopping cart view, the kind of common one would be to materialize the current state of the basket, of the shopping cart. But it also could feed an analytics system which kind of tries to correlate items which are similar and stuff in a completely independent way. So what we took away from that, and what was important to us, was that for a given piece of domain, we have one data owner service, which coordinates the writes. And that's the system which persists the version of the data in the primary source of record, its database. And it publishes an event that this kind of update happened. So a message got published. This message got created. And we have multiple view services which listen to those events and update their local state based on a DB. And the reads are served from these services. So what we're after is changing this into something more like this. I mean, I haven't redrawn that diagram, and it's just more high level. But think of it this way. A message comes in. There's a data owner for the message model. It publishes to an event log. And then we have a view for a group. So it materializes the group view where that message was posted. The inbox, so it delivers to all the people who should get that message. Potentially a system which reacts to a message and sends real-time notification, push notification to mobile clients. There's a subscriber which listens to those events to see who messages with whom, so we could provide better relevance. But what's crucial, all these systems are completely independent. So if one of them fails, none of them are affected. Adding a new feature, which, I don't know, checks which tracks when the user was online so that they can maybe send them a summary if they were offline, is just adding a new subscriber, completely independent of previously existing features. All it cares about is messages being sent, read, and this kind of stuff. So why is this appealing to kind of, if we are looking to solve our previous problems? Well, we have less, like those view services, because they provide materialized views, we have less runtime dependencies. That affects our SLA, but also our performance. We have much less chattiness, which again, it's good for performance, but also helps our velocity because we kind of operate within a single service when we are developing a feature. We have loose coupling. It's a variant on chattiness and runtime dependencies, but the application is generally more modular. So, and we publish events, not commands. I think that's an important point. That's probably one of the bigger challenges of rolling this out. Because we so often used queues in the past, people tend to think of in terms of publishing commands, but commands provide coupling because they are from a particular sender to a particular receiver. And what we are after here is about a universal message which everybody can subscribe to and take whatever they want. The difference is instead of do this, said I did this and you do whatever you want. You know what you should do. And in a sense, it also provides better encapsulation of services because the recipient knows how to react rather than the emitter. And it also makes it cheap to set up and backfill a new service and start using it immediately without affecting anything else. So what were the challenges we faced when we started rolling this out? So first of all, it's a big change, so we can't roll it out overnight. But more importantly, there are quite a few risks associated with it. What we looked at and what we've seen in the past were typically toy examples, which you see during conference talks, which kind of are focused on exemplifying the idea. But they have no way of addressing the real pain points you'll experience when you run this kind of approach in production on a complex system, which is constantly changing. And so the concerns we had was, can this actually deliver? Like, will the benefits not be outweighed by the costs which we will face? How long will it actually take for us to learn how to do it properly? I mean, we haven't done it before. And what stack to use? This will require some sort of middleware in our application. And like, what is the cost? Like, what's the cost of onboarding the technology which was used by that stack? Because you need to train people how to deal with on-call issues. You have to make sure that this happens across time zones in a sustainable fashion. So these are actually high risks and potential high costs. So at a high level, we had two challenges. We needed to validate event sourcing, see if it's actually worthwhile. And if it is, we wanted to choose the best stack. But ideally, we would like to decouple these two. We would like to first validate before we make the big investment in the tech stack. So because if we validate early and deliver value early, then we actually have tangible evidence that we need to invest in choosing the tech stack. So what we did was we chose a legacy system, which we had. It was called Vent. It was at some point intended for eventing, but it was used in one particular scenario. And it was kind of forgotten. And it also had a somewhat awkward design because it was fronted with an HTTP proxy based on Dropwizard. It was called Sync. Then there was a Kafka backend, and there was a HTTP spout, which was, again, a Dropwizard service, which was subscribing to Kafka and relaying events which it read. And we had some operational experience with Kafka because we use it for our logging pipeline. We also use it for we used to use it for our metrics shipping pipeline. So importantly, so this system was allowing us to model the kind of pub/sub event logbacks concept, and it was built of components we're familiar with. Even though it was super centralized, so it provided, again, a single point of failure, and it had a lot of craft, which wasn't really clear why we needed it long term, as in these are maintenance costs, failure points, etc. Actually, the reading part is a single point of failure. If somebody breaks the config, they can potentially take the whole application out. But crucially, it was built of familiar components. We're already operating relatively well. So that minimized our tech risk and allows us to focus on validation. And one of the downsides, which is centralization, actually short-term was a benefit because it allowed us to iterate quickly. If we were to update all the clients all the time, each time we discovered something, we did something wrong, it would be a massive pain point and slowdown. So the work we did initially was we operationalized that system further. So we made sure that it doesn't have some critical bugs, which it had because it was somewhat neglected. And we worked out an API and semantics, which was independent of the implementation. This was something which could move forward even if we remove the proxies and we started using pull model versus the push model, which the HTTP proxy kind of enforced on us. And we also built tooling, which actually made it easier for our customers, which built consumers of the event streams. It allowed them to monitor the health of the consumer as well as managing the events. And we built end-to-end test suites, one kind of around correctness of the system, like not losing data and stuff. Kind of important if it's treated as persistent. And we also created throughput and load tests so that actually we could comfortably iterate on the system without risking performance degradations. And this is quite important because this will help us relatively quickly to move to the next stack, like the stack of choice, once we think it's worthwhile. So to give you an example, we made it possible to generate this kind of dashboards for every consumer very easily. We use a tool called Wavefront. We push our metrics to it, and this is our visualization. So on the top left corner is probably the most important, top left, yeah. Most important metric is the consumer lag. If the consumers are lagging too much, it basically means, well, they're in trouble. So that's probably what people want to monitor. An important thing of that, of Wavefront is that actually it makes it super easy to programmatically and automatically set up alerts. So this kind of removes a lot of friction around setting up a new consumer and providing a quality experience. But we also have more kind of fine-grained view, like how end-to-end latency, processing rates, type of errors we see, etc. So this is, but we also provided management tools. So this is like a thing which an edge case we have to face when you do this kind of transaction log system is you actually can end up with events which are logically corrupt. I mean, we are hoping that the system itself doesn't corrupt messages. I think there's a version of Kafka which actually corrupts you have to work around the data corruption when using Snappy, but that can be resolved. But at an application domain level, you will also have poison pills, which basically messages which the consumer cannot process and doesn't know what to do. So this tool basically allows us to, once we detect that the consumer is stuck by its lag growing, we can actually investigate why. If we know it's not the consumer failing because of operational reasons, we can actually look at the message which causes the problem. We can put it to hospital to unblock immediately and have quick mean time to recover, like good MTTR, and we can actually look at it and investigate it and see what's the actual cause and what's the long-term resolution. This unfortunately is used quite a lot. But the ultimate validation of the idea is to have projects or systems which benefited from what we did. And this is the view by the end, I think, end of October last year when we finished this first phase. Its focus is on messages creation because this is the topic common to all the components which I listed here, but there's more. Basically, yeah, this is the core event, messages created. In the past, our Rails application would post this event to multiple Rabbit queues, and then each pipeline would have its own worker doing something. Now it actually is posted once, and everybody uses the same event. It helped rewrite it really helped our rewrite search project. We moved to Elasticsearch from a custom solution. It helped our data export project, which is very important for our customer for legal reasons, but was very old and frequently failing. And it also helped our message delivery. As I said in the past, there are multiple views. We materialize them on write. In the old system, this was done in one transaction. And these aggregate views, like for people who follow me or etc., they're complex and costly to compute. So they actually could cause failures on our inbox and group delivery. Whereas probably people don't care so much about the aggregations, whereas inbox and group delivery is super critical, and we want to decouple them. And this event log concept made it very easy to actually do that. So what kind of problems we faced? Because it wasn't all rosy. So this was actually probably one of the biggest problems which we still haven't resolved. We're kind of turning a blind eye on it. So what to actually publish in our events? Because ideally, you would publish IDs, like this model changed, and this is the version after the change. So you can actually access the state at the event emission time. But that requires immutable version data, which we don't have in most places. And it also requires you to have uniform resource identifiers done well. I mean, we obviously do have those, but many places they follow very different conventions. So we are trying to address this, obviously, but this is a transitional problem. So I think in quite a few places where the size was actually a problem, we actually were lucky enough to have version data, and we use actually identifiers. But in other places, we are publishing the whole data where we can, or we are trying to work around this. But ideally, you want to go to immutable data and URIs. And something we've discovered is actually that as the application grows, while there's a single model owner which coordinates the write, actually, as we build features, we enrich the model. So the different enrichments may have different owners. But it's because we don't want to have a topic explosion. We want to have it conceptually grow with the number of models we have, not with the number of features, which come and go. We will want to share a topic. And we had to actually learn, this is something we were challenged. Initially, we were kind of lost, like our consumers were failing because somebody started publishing something new. And that's why this tool I've earlier showed about for handling bad messages is used quite often. But yeah, at the moment, I think it's it doesn't happen. I mean, we've learned how to write our consumers in a resilient fashion. So we know what we are interested in, and if it's not what we want, we can skip it and just move on. So yeah, we learned that we are actually sharing data streams and that this can be costly. There's also adoption challenges. This is kind of a more organizational problem than software architectural problem. It is a big paradigm shift, especially this bit moving from commands to events. And we have 3 offices in 2 time zones, and there's an 8-hour difference. And the team which develops this, worked on it mostly, is in London. So knowledge dissemination in an organization of, I think, 200 engineers takes time. At the moment, it means that I quite often am on a call late at night, trying to help people start using this. And long term, I'm hoping, as people use it more, there are more examples, it won't be required. But this is a cost. But furthermore, we are actually not experts on this either. I mean, we are probably working closest to it, we know most about it, but we're still learning. So that's also something we have to accept. But good news is that even if it's imperfect, it actually had a big impact on our work. It really helped. It really decoupled a lot of teams, allowed them to build things faster and in a more resilient way, dealing with performance, reliability concerns much later than they usually would have to, because they work in isolation of other components. One thing which we discovered, and we kind of didn't know explicitly before, I mean, it's no big news, but it was something which came out of this work. It was hidden in our system before, that we have workflows. So basically, what I've highlighted is one of the workflows which is quite explicit in our pipeline, is this delivery to inbox, group, and aggregations is actually, it has to be coordinated to an extent. And the coordinator is the delivery service. That's a service which listens to some events and translates them to events which then those systems listen to an extent. So they use the event log. It is an OK usage. But actually, we have to do a lot of plumbing, as in we have to actually make sure, we have to maintain a state machine. We have to make sure that things transition correctly. This is long term, we don't want to do that manually. We want this to be solved for us. We want to have a higher level of abstraction. So more or less like this. An event that the message got created comes in, the delivery system picks it up, and it distributes the task to the 3 different deliveries. And once it's finished, it's like a fork join type of job. Once it's finished, it publishes back the state change. OK, this message has been delivered. You can maybe notify the mobile clients because the view is already persisted. So if you look at it, what workflows really are from our point of view, this is like a transformation logic which lives outside of the view service boundaries. It's quite often more complex. It might require retries if you want to maybe scale it out. Because it's especially like a good example where you want to scale it out is we have something called an announcement. A group can have up to 30,000 people. When you post an announcement, you want to deliver that announcement to everybody. That's a big fan out if you're doing materialization on write. So you would like to you want to chunk it up, do some of this work in parallel, and retry the jobs that failed. So this is effectively stream processing, CQRS kind of conceptually. And yes, we can express them, but as I said before, we have to do too much manual work about setting up the coordination, whereas we would like to just model the workflow, because that's the domain model. It's a workflow. It's not whether we publish to this and read from that. So we basically are looking for a higher level of abstraction. And I will come back to this later in the talk. But this is the kind of thing we've discovered, and this is like an open problem for us. So what's the future? Because this is not finished work. So we want to move to a fully managed solution. So as I've mentioned earlier, we are running Kafka, and we actually are running it in our own data center, which basically means a lot of headaches, dealing with outages, like host going down for physical reasons, the actual instance having problems because of something. And if we want to scale, we have to do it effectively manually. So that's not great. That costs us operational resources. We would like to provide Rx bindings, because as it's like event log is effectively an event stream, and Rx is so well suited. So how many people used Rx just to? OK. How many people are familiar with it? OK, so it's basically reactive stream processing. So I think like looking at talks about Flink, I think it exposes a similar API. Basically, you have a stream of events you can map, you can filter, you can aggregate, etc. It comes from, I mean, I don't know where it was originally invented, but it's been popularized by Netflix recently. And we want to remove the centralization HTTP proxy, and that Rx library would be very useful to that. And we want to find a solution for the workflows. So we have ongoing, so coming back to this managed solution, we have an ongoing migration to Event Hubs. Well, we are a subsidiary of Microsoft, so it's kind of natural to go to Azure. But Event Hubs are basically an event log offering like Kafka or Kinesis, but it's fully managed and hosted in Azure. So that means that for us, if a host which is responsible for some partitions goes down, that happens behind the scenes. We don't know about it even. We don't have to deal with provisioning in any way. We just simply move a slider. We have more transaction units. So that's a big operational benefit for us. It's AMQP 1.0. Well, it uses that protocol. So that means interoperable. It's not tied to any particular language. It's successfully used internally and externally. Actually, we have already migrated our Kafka, metrics Kafka, to this to Event Hubs. The reason it's a different concern for us to move this part of the system to Event Hubs is because requirements are very different. Metrics can lose data, and obviously we don't want it, but it's acceptable. And it's obviously throughput-oriented, whereas we are much more latency-oriented. And like we want to minimize latency because it drives user experience, and we cannot lose data. We want to publish synchronously. We are also working, as part of this work, we are building the Rx Java Sdk. We are building it on top of the Azure Sdk, which is provided by Azure Service Fabric team. The SDK is powered by ProtonJ, which is, I think, the only implementation of AMQP 1.0 at the moment. But it provides also some sort of higher-level concerns for us. It deals with higher-level concerns which we don't want to deal with. Basically, it provides us offset tracking, so it allows us to keep track where in the event stream we are in case of a restart failure in this kind of scenario. Plus, I assume everybody is familiar with Kafka, but just briefly. In Kafka, there's a concept of a topic, and that topic is sharded across multiple partitions. That allows to scale processing for throughput. But what that means, in our kind of scenario, we want to have one consumer per shard, because we want to process events sequentially one after another. So the problem we are facing is, if we are scaling our consumers out, while we try, one of them can die at some point, and we want somebody else to resume, but we want to have only one, and we want to have them evenly spread across the VMs. So that's an interesting problem, but it's not our business domain, so we don't want to deal with it. So that's why we are using the SDK from Azure, because there are, for instance, JMS bindings if somebody is not so much interested in these issues. And we're effectively raising the level of abstraction. We hide the whole AMQP tracking, failover kind of business, and we're providing an observable. Here you go. There's your stream of events. Map it, transform it, do whatever you want. But this is ongoing work. And going forward, yes, coming back to the workflows, this is something which is more in the future. We're looking to use Azure Service Fabric reliable actors. This is a high-level PaaS offering from Azure. It's quite widely used within Azure. It powers, I think, Event Hubs and all the management sites, for instance, for Azure. It's based on a Project Orleans. This was a research project which I think has an open source implementation now. It's came out of Microsoft Research, and it was actually successfully used for Halo to keep track of user stats. They use actors to represent users, and they manage all the kind of loading, unloading from memory when the user comes online, and it allowed them to build a very responsive and highly scalable experience for Halo. So, yeah, to summarize. And yeah, by the way, just to finish up, this is publicly available. I think it's available for .NET, but they are working as we speak on the Java Linux setup. And you can actually run it locally as well, if you want. It's pretty easy to use. So just to summarize, we successfully used event sourcing to solve our SLA and velocity problems, which we inflicted on ourselves building a massive monolith and then distributing it. It actually helped us address both architectural and organizational aspects of the problem, which was nice. What was important for us in actually getting this project through was that we focused on an iterative approach, which allowed us to reduce risk and deliver value early. And this is still ongoing work, so yeah, it's not finished, and hopefully it will continue. So yeah, thank you. Are there any questions?
Thank you for your talk. We just have 2 minutes. The question needs to be really short. Sorry, talk. Because we have a closing session.
Oh, do we? Okay.
At 6.
Well, actually, I have 2 questions. The first one is, how do you deal with the long-term persistence of the events? Do you store them for longer than, well, maybe a couple of days, or how do you deal with that? And the second question is, how do you process failure in the different consumers? What happens if there is some bug in the consumer? The typical approach in event sourcing is to just recalculate the whole log. How are you dealing with that?
So we wanted to have this kind of ideal scenario when Kafka or what comes next is kind of the whole log. Unfortunately, we cannot do that because we have compliance concerns and we have to enable easy deletion of PII data, and that would be very difficult to do in Kafka. Basically, our customers, when they stop using Yammer or Office 365 offering, they have a guarantee that within some number of days, their data just disappears. So for that, we actually use that's why I mentioned that there's this data owner who persisted to its database. And then, so we use Kafka or event log a bit like more like a transport layer at the moment. So if we need to, we could like if we move to immutable version data, we could use the primary data source, which is the data is written in the service which receives the request before it publishes to the event log. We could use it to regenerate the events and get consumers to reply. And the other question was, it was like about restoring a consumer. We actually recently had a scenario. We restored it from backup and replayed the difference.
Do we have more questions? Can we please take it offline because we have a closing session now in Castle House.
Okay.
Thank you, ladies and gentlemen, for your presence. Thank you.
Thank you. Okay.